Hello and welcome to today's video. Today we're taking a quick look at one of my projects, which is an electronic dice project. I'm new to using the Arduino system. I've used many other microcontrollers and larger processors, DSPs, FPGAs, different things. But I'm interested in what the Arduino is capable of, particularly the Nano, some of the smaller, cheaper devices. And I'm just using this time just to learn what it can and can't do. And I thought an electronic dice is just a fun little project to get started, because I only need the Arduino Nano and a display and a button. So it's something very simple to do. So with that, let's take a quick look over onto KiCad. So this is my circuit or prototype board I've set up. I've got a single I2C interface running at 3.3 volts, and bus speed is, I think I'm using 400 kilohertz. All of these devices work reliably at 400 kilohertz. Now, I do have a rotary encoder and a push button switch over here with some logic debounce circuitry. But basically, we're only using the switch at the moment. We have a switch. I'm doing a debounce circuit externally, but there's no reason why you can't do that in software. A lot of the time, it's an interesting design topic which people often overlook. So it's interesting. I in my day job I did a lot of work with cell phones, making cell phones, designing cell phones for pretty much every carrier and every operator around the world. So Apple, Android, Google, Microsoft, LG, Casio, Denso. These are some of the old ones, but there were thousands of cell phones, and people don't realize like a typical production run of a cell phone may be 1 million devices. So when Verizon or AT&T go to place an order, they may order 1 million cell phones. Now, every penny or cent in America that you can save on that implementation, you know, if you're selling 100,000 or 1 million phones, if you save 1 cent, that's a significant saving. You know, you end up saving thousands of dollars. So there's a lot of cost optimization, and a lot of the design goes into little things like this debounce circuit. Well, at production values, when you're talking about 1 million, each one of these components is less than a cent. But you can say, okay, maybe that's like 1.5 cents. If you're making 1 million of these, you really need to ask yourself the question: is it worth that cost, that $10,000 extra cost for adding in these components? If you've got the processing capability in the control side, in the microcontroller, it might be cheaper to do that programmatically as opposed to electronically. But also, consequently, if you're trying to make a very low power microcontroller which has minimal memory or RAM, adding in a software debounce bit of code may cause you to use a more expensive microcontroller. You know, you can get a microcontroller which costs maybe 2 cents. If you have to go from 2 cents to maybe 5 cents for the microcontroller to add in debounce software into the microcontroller, it may be cheaper to add the 1.5 cents to do it electronically. So there's never a one solution that fits every problem. As an engineer, we need to work out, there's many different ways of solving the problem, and if cost is a driver, you need to understand where the pros and cons are with all of these implementations. So anyway, that was just a quick aside. Okay, sorry about that. So anyway, so getting back from that little aside to what we're talking about today, which is my dice demo project. So we're using the little switch just to start rolling the dice. Obviously the program is running on the Nano, and we're going to display the dice on the OLED display. So that's a little bit about how it's going to be connected. So let's switch over to the software. Okay, so here we have my dice project. So I've actually created my own little class for controlling or performing the dice rolling and everything. So to use it, basically we just create an instance of my dice object. Then we initialize it with the standard begin function, and here I pass in the object for the display object for the OLED. Again, I'm only using the SSD 1306 or Adafruit library is the one I'm using here. If you go to, I've got a link in the comment section below. If you go to my website, I have a web page which details all of the versions of the libraries that I'm using, as well as information on the source code. And if you want to download and play with it yourself, you're more than welcome. So we pass in the display object, and then I've got a value for true or false. This is just basically, I started with drawing an outline of the dice. So it's just like a little outline shape of a dice and little circles for the dots in an outline mode. But then I changed this to true. It becomes more of a solid looking dice. So it's just how it looks. Again, I did this just as a bit of fun. Just to drive the I2C interface a bit more and try to find some little issues with the display. In fact, actually, I did find issues with the I2C and the Adafruit library with this. If you actually download this project and start looking in the CPP file, I'll show you in a second, I have options to enable text on the dice. So at the moment, by default, it's only like a D6, just a regular standard dice, or maybe a D4. There's options to do if you wanted to do a 4-sided dice or a 6-sided dice. But in the code, there were options to do up to a 100-sided dice, and the text, it displays a text value as opposed to dots on the dice. And I found a couple of issues. When I do that, I've got options to do multiple size dices, up to 5 dice, which required me to load, I'll just show you, which required me to load 3 different font sizes. And when you do this, you really these take a lot of the memory and cause some issues. So basically, if you fill up all of the memory, what I actually observed was I was seeing a corruption of the display on the OLED in the corner, sorry, in the bottom right corner. It wasn't giving me an error in the code or any problem like that. So I believe that there is an overflow issue somewhere within the Adafruit OLED display driver, which when you start running out of memory or getting low on memory, it causes some of the screen memory to get corrupted. So anyway, so for this, I'm just learning. Didn't really matter. So I just set some flags to temporarily comment out the code for text. But again, feel free to download the code and play with it yourself. So to use it, basically, we do the create instance. We just do begin. And then if you wanted to, these are optional. You can set the number of dice. So you can have between 1 and 5 dice displayed. And then, as I said, the dice type. So basically, this is the maximum number that's going to be shown on the dice. You can do, in theory, 2 to, well, I set it to D4 or D6. D6 is the standard. And then when you want to roll the dice, well, you just call my dice roll, and it is a blocking function, so just be aware. I set the roll to take, less than a second, and then you see the result appear on the display. So I'll show you that in a second. But there are some interesting little pieces into this code. If you've never played around with random number generators, this is actually an interesting little topic. So if we go into the CPP function, you can go through and see the code. But I have this little block of code here. So I've got a flag called randomized, and then a random seed in mils. Now, if you've never used a random number generator, it's interesting to play with. If you call a random number generator after the power cycle, you will get a sequence of totally or pseudo random numbers. And if you analyze that number set, they come out as a random set of numbers. So I tried it. I did 10,000 samples, and you truly get a random value. Each value is equally likely. So it does randomize the values. But if you reset the Arduino and you run it again, you will get exactly the same series of random numbers. So although the numbers are random when they start, it's predictable, or the sequence is predictable. And this is a classic issue with random number generators on computers. No computer can truly produce a random number. In fact, I've got a project coming up where I will be producing truly random numbers, and I will be using a radio receiver to use background white noise to generate a truly random number, which is an interesting topic on its own. But anyway, what I've done here is I'm using this mils function. Mils basically is the milliseconds from the time the Arduino started. Now, if you just, and random seed basically sets a random starting point in the random number sequence. So if you just use this command and you place this in the setup function, you still will get the same random sequence number. It will be different than if you didn't have this random seed mils, but it will still be predictable. So the way I've made this truly, or less repeatable, I should say, is I'm taking the mils value from when a person first presses the button to roll the dice. Now, the chances of anyone pressing the dice roll button to the millisecond more than once or twice produces a much more realistic random number generation. You don't really need to keep creating a new seed value every time the button is pressed. So all I do is I set the new seed value from the very first time the person presses the button, and then from then on you'll have a different randomized set of values. But that's an interesting gotcha. If you didn't understand what was happening with the random number generator, you'll see that you just get the same numbers each time, which if you don't tell your friends and you're using it in a game might be good to your advantage, but after you've used that system once or twice, I think your friends might notice it always produces the same sequence. Anyway, now it's just a little bit aside. So now let's switch over and I will show you it working. Okay, so I think I'm going to leave the video there. If you've got any questions, please feel free to leave them in the comment section below. If you want more information about the project, I have a link in the description which will take you to my website where you can actually download the code and see a bit more about what I did. Please feel free to download it and play and look at the code. But thank you for watching and have a great day. Bye for now.